Hello everyone and welcome back. I hope till now you all are able to design the finite state machine for various applications such as finite state machine as a divisibility tester wherein we had designed it for different number systems. Then we started designing finite state machine as a string validator wherein we had seen it designed for ends in, contains and starts with type of string validations. In today's session, we will be seeing some of these combinations in designing the finite state machine. So, let us see our first question for today's session. The question says that we have to design finite state machine such that the input is validated if and only if it does not contain any occurrence of a double letter over the input 0, 1. So, step number 1 of the solution is theory, that is definition of our finite state machine. Step number 2 is logic, wherein our I is already mentioned in the question as 0, 1, O is y, n and our S is Qs, Q0, Q1, Q2 and Q3. So, let us see what each of these states represent in our state transition table. So, here we have Qs, Q0, Q1 marked as our final state. We have Q2 and Q3 which are not marked as final state. Q0 represents 0, Q1 as 1, Q2 0, 0 and Q3 1, 1. Since the question says that it should not contain any occurrence of double letter, so we have to mark Q2 and Q3 as non-final, whereas Qs, Q0 and Q1 are all final states. So, let us see the state transition table. From Qs, we will be going to Q0, Q1 respectively. Then from Q0, we will transit to Q2, Q1. From Q1, we will go to Q0 and Q3. From Q2, we will stay in Q2, Q2 and in Q3 again we will be staying in Q3 itself. So, here Q2 and Q3 will be treated as our dead states. So, in MAF, we will mark Q2 and Q3 as no, whereas Qs, Q0 and Q1 will be marked as yes, that is the input string is valid. Let us check out the state transition diagram. So, we have Qs, Q0 and Q1 marked as final state in our state transition diagram, whereas Q2 and Q3 are not marked as final state, and once we reach either Q2 or Q3 state, we have to stay in the same state. Whereas, if we go in either of these states, then we will get the output as yes, the input is valid. Let us check out the examples. So, here we have taken two examples wherein Qs 0110 is one example and Qs 010110 is another example. So, here as you can observe that we are getting a double one. So, we will reach Q3 state and stay there till the end of our input string, whereas in the second example we will reach Q0 state at the end and produce the output y, that yes, the given input string is valid. Another way of framing this question is design an FSM in which the input is valid if it contains alternating sequence of zeros and ones. So, let us see our next question. We have to design finite state machine such that the input is valid if it contains even number of A's and odd number of B's over the input A, B. So, step number 1 is theory, definition of finite state machine. Step number 2 is logic, wherein I is A, B already mentioned in the question, O is y, n and S is Qs, Q0, Q1, Q2 and Q3. Let us see the logic for designing the FSM, wherein we have to check whether it contains, the input contains even number of A's and odd number of B's. So, let us see the logic. So, here when we say that even number of A's and odd number of B's are contained in the input string, it can appear anywhere in the string, but it should appear as even number of A's and odd number of B's. So, when we have A, so here it is odd number of A and even number of B. Since when the first input symbol is taken, it will be as first, that is odd number, and since there is no other symbol appearing, B will have even number, that is zero occurrence of B, that means even number of B's. So, here this will become one state wherein we count even number of A's and odd number of B's. Then we have to count odd number of A's and even number of B's Other than that, we will have even number of A's and even number of B's. Finally, odd number of A's and odd number of B's. So let us check out the state transition table so that we get much more clear idea about how we will be transitioning from one state to another state. So let's go to our next slide. In this we have our state transition table, wherein from QS we are transitioning to Q2 and Q1. Why is that happening? Because in our state transition table, as we can see, Q0 is representing even number of A's and even number of B's. Q1 is representing even number of A's and odd number of B's. Q2 is representing odd number of A's and even number of B's. Finally, Q3 is representing odd number of A's and odd number of B's. So when first input symbol, if it appears as A, it becomes odd number of A's and even number of B's, since B is 0. So we will transit to Q2 state. When we get the first input symbol as B, then it will transit to Q1 state, because then it will be even number of A's and odd number of B's, that is 0 number of A's and 1 number of B. Then when we reach Q0 state, the previous state was such that we had found even number of A's and even number of B's. So once when we get the next input symbol as A, it becomes odd number of A's and even number of B's. That means we will go to Q2 state. Then if the next input symbol is B, then it becomes even number of A's and odd number of B's. When we reach Q1 state, the previous state was such that we had even number of A's and odd number of B's. If the next input symbol appearing is an A, then it becomes odd number of A's and odd number of B. So we transit to Q3 state. If the next input symbol appearing is B, then it becomes even number of A's and even number of B's. So we transit to Q0 state. When we reach Q2 state, that means we had encountered odd number of A's and even number of B's. So after this, if the next input symbol is appearing as an A, then it becomes even. If next input symbol is B, then it becomes odd and odd. So we go to Q0 and Q3 state respectively. From Q3 state, since we had odd number of A's and odd number of B's, if the next input symbol is appearing as A, then it becomes even and odd. If the next input symbol appearing is B, then it becomes odd and even. So we go to Q1 and Q2 state respectively. I hope the logic for designing and understanding that we have to count the number of A's and B's to be even and odd respectively. So here, even though the question had contains, there will be no trap state. Instead, we have to scan the entire input string till the end and decide whether it had reached the final state of Q1, that is even number of A's and odd number of B's were found in the input string or not, and generate the output yes, that the input string was having even number of A's and odd number of B's. Now when we have the MAF other than Q1, rest all will display no as the output and Q1 will generate Y as the output. Let us check the state transition diagram. So here as we can see that we have QS, Q1, Q0, Q3 and Q2 states, which are representing our even and odd states of our A's and B's. So if we consider the example A, B, B, A, B, here from QS we will transit to Q2 state. From Q2 state we go to Q3. From Q3 we come back in Q2. From Q2 we go to Q0 state, and from Q0 we are reaching Q1 state, generating Y as the output, that is the input string is valid. Another example is A, B, A, B, A. So here from QS we are going to Q2 state. From Q2 we go to Q3. From Q3 we go to Q1. From Q1 we are going to Q0. And from Q0 again we go back to Q2 state. So since we did not reach our final state Q1, we can easily conclude that the given input did not contain even number of A's and odd number of B's, thus generating the output no, the input is not valid. Let us check out another example. Designing finite state machine wherein the input is valid if it contains B at every even position over the input A comma B. So step number 1 is theory, that is definition of FSM. Step number 2 is logic with I, O and S defined by AB, Yn and Qs, Q0, Q1, Q2 respectively. Let's check out the state transition table so that we get to know what do we mean by finding that every even position is having B in the input given string. So here when we say that every even position, so there are going to be some positions of our input string. So when we count, this is 1, this is 2, this is 3, 4, 5 and so on. So here this 1 is representing odd position, 2 is representing even position, 3 is representing odd position, 4 again represents even position. So here in our question it says that every even position should have a B. So every 2, 4, 6, 8 and so on positions should have B in their input string. Odd positions can contain either A or B, it doesn't matter. So we will see how this transition table works. So when we are in QS state, when first input symbol is appearing, we are going to check for odd position. So odd position is represented by Q1 state. So we go to Q1 state. Why? Because in odd position, it doesn't matter what is appearing. Next, when we are in Q0 state, that means we have reached even position. So we are at second position for example, and next input symbol appearing is either A or B. Again it is checking for odd position. So we will still go to Q1 state. Next, when we are in odd position, say either first position or third position, then in such situation what we have to check is what is appearing in the even position, that is second or fourth position. Now here in case A appears in the even position, we need to send our machine into dead state, or else if B is appearing, it will go to Q0 state. And when we reach Q2 state, it will stay in same state. When we have to design our MAF, here we need to make sure that wherever Q1 is appearing, we will give it as yes, and wherever Q1 is not appearing, that is if it is Q2 or Q0, we will put it as N, that is no, the input is not valid. I hope the positions have been clear to everyone. Let us see the state transition diagram and get much more clear idea about what exactly is happening here. So here as we can see that Q2 is a dead state, whereas Q1 is our final state, and from QS we either go to Q1 state or Q0 state. In case at even position if A appears, then we will be sending our machine into dead state and stay there till the end of our input string. You have some examples to solve, wherein one of the examples should give you the output as yes and another should give you the output as no. In case you still have any doubts or any queries regarding some of the questions that we solved in today's session, leave out your questions in the comment section and we will check out and resolve it in our next session. So see you then.